I think we talked a little bit about where carbonaceous chondrites come from and what they are. Maybe you can expand a little on that concept.
Part of this slide was just me being really fascinated by just how much we've learned in the last couple of decades. But the point of it can be summarized as there are a lot of theories about where carbonaceous chondrites come from, but we still really don't know. So depending on who you ask, and I would say it's at least 75-25 probably. Some people think they come, or we know a lot of them come from the asteroid belt, but carbonaceous chondrites themselves, are they asteroids, right? Are they something like Ceres, for example? Or a lot of people think that they could be comets. So, yeah, in this case, I just thought it was really neat that in 1974, that's what we thought of as a comet. And now, thanks to Stardust, which was the mission that brought back pieces of a comet, we have a much better idea of what they look like. And actually, when we look at those little grains from a comet, they're grains of things in meteorites. So, very similar, I guess, in terms of, the minerals you might expect in a carbonaceous chondrite. And then I think Brittany mentioned this in the last episode of the Ceres series, that recently it's been discovered that they're main belt asteroids, so asteroids in what we think of as stereotypical orbits, but they have ice in them, and if they get hit by an impact or something else happens to them, they look like a comet would, except unlike comets, which go out to Jupiter or out into the Oort cloud and then back towards the sun, these guys just kind of hang out in their standard orbit and still display this evidence for water. So it really kind of blurs the lines of what's an asteroid in the first place and what's a comet in the first place.